Okay, welcome everybody to our SAE event hosted by Collins Aerospace today. Just a quick check, Dan, can you see my screen okay with the presentation? Yes. Okay, well, thank you everybody. I'm John Messina, I'm the Vice Chair here at SAE Chicago. Thank you for taking time out of your lunch hour to join us today. We have hopefully what is an exciting event to bring to you today. This is one of our first events of this new fiscal year for SAE. So just a little background on the SAE Chicago section. We're one of the largest sections and the most active sections in the entire country. We have over 200 member companies, over 1,000 total members. That includes professionals and students. We specifically partner with the universities that you see there. University of Illinois, Chicago, Northwestern, Northern Illinois University, Illinois Institute of Technology, and Bradley University down in Peoria as well. So if you know any students that are majoring in engineering, or if you have any friends that are in the professional field, please let them know about our section because we host some great events, and you can see there a lot of benefits, networking, company tours, opportunities to get involved, technical resources, and professional development opportunities that we offer, both professionals and students. Here's just a small snapshot of the over 200 companies that we have in our section. You can see they range from anywhere from big, well-known names like C&H Industrial and Caterpillar to smaller type firms like ESI and Elite Electrical Engineering on here, and really everything in between. So great opportunity to network with people from a wide cross-section of companies that have individuals or are headquartered here in the greater Chicago metro area. Here's our current officer roster. You can see diverse section of people from across a lot of the companies you saw on the other slides and others. If you're interested in getting involved, we do host a monthly meeting. If you're not sure how you'd want to volunteer or what capacity you want to volunteer in, you're welcome to sit on one of those meetings, see what we do, and then potentially join either a committee or even eventually become an officer. We'd love to have you. We're always looking for more people to support us and get involved and help SAE's mission. So with that, I'd invite everybody to follow us on LinkedIn, on Twitter. Check out our website at chicagosae.org. We do have a Facebook account now as well. Our board meetings that I mentioned, those are the second Tuesday of every month. If you're interested in joining one of those to see what we do, they're held over Zoom as well. Shoot us a note, let us know. We'd be glad to have you come in as a guest. We are also getting back to in-person events, which is exciting. Our new schedule will be kind of a hybrid mix of virtual events like this, as well as face-to-face events. So our first one is with Elite Electronic Engineering. It's their November Fest, not to be missed. They show us some great technology that they have. This one will be focusing on EMI shielding in the electric vehicle market, I believe is the topic. And that is Wednesday, November 16th, although that date is still yet to be confirmed. But follow us, check out our website. You'll make sure you'll see that date for that event. That'll be a great one. So now going on to today's event. Today's event is hosted by Collins Aerospace out of Rockford, Illinois. Today's speaker is Bob Myers. He's the RAT Wind Tunnel Project Technical Lead responsible for mechanical, electrical, software applications. He holds a BS in Mechanical Engineering with minors in Electrical and Computer Engineering from Purdue University. Today's event qualifies for one professional development hour. Certificates will be emailed to those who requested one at registration. If you did not request one at that time and would like one, please just simply email the section and we'll make sure you get your certificate. I'd also like to thank Dan Ezanecki. Dan is from Collins Aerospace as well and helped arrange this particular presentation that we have today. So with that, I will be turning things over to our guest here. It's gonna be 1 second. Bob, who's gonna go ahead and open up the presentation. Bob.
All right, thanks, John. So as John mentioned, this presentation is focused around our new RAT wind tunnel that we developed, built here in Rockford. We started design on it in 2020, and just this summer got it all commissioned, set up to run our first RAT. So although it's focused more on the wind tunnel itself, I'll start with an overview of what a Ram Air Turbine is. I'll talk about what features of the rat we need to test for acceptance, and then I'll get into the details and more specific on the equipment in the test facility. After that, then we'll have a few videos to share. I'll walk through the facility and show some of the equipment actually operating in a rat spin-up. So starting with the overview of the rat, here you can see a couple photos of them. What this piece of equipment is this is emergency power generation. It's the last line of defense for an aircraft if all else goes wrong. The turbine deploys out the underside of the aircraft and uses the aircraft's velocity and relative airstream to turn the turbine, which on the driveline is connected to either a pump or electric generator or both to provide emergency power to land the aircraft. So why does this equipment exist? Well, here's the FAA regulation that drives it. You can see an airplane must be designed so it's controllable if all engines fail. Some events that can happen that would cause all engine failures, fuel exhaustion, fuel contamination, volcanic ash, bird strikes, rain, hail, or human error even. So this power source must be independent of the engines. Engines driven electric power generation system must be provided to permit in-flight engine ignition for restarting, and provisions to complete flight and make a safe landing in the event of a failure of all normal generated electrical power. So again, the FAA regulation here driving this piece of equipment, where if all else fails on the aircraft, there must be something in place to help the operator land safely. So here's some options for that emergency power source. The Ram Air Turbine is the most commonly available in the industry, is what we as Collins provide our customers. But you can see some of the other options here and some of the limitations with those options. Here are a couple photos of aircrafts where the rat was deployed. You can see the history really of this product. It's been around, installed in aircrafts for decades. And this chart here showing, I think, all of the events in which a rat was deployed and required to safely land an aircraft. So although it's not very frequently used in all the flights that have happened over the decades, you're really glad that it's there. And those 26 aircrafts and over 2,300 people on those flights. Very fortunate that this piece of equipment exists. So I mentioned earlier, there's a few different configurations of the rat. The primary purpose is to provide either electrical, hydraulic, or both forms of energy. So electrical would be for in the flight deck and to operate some of to actually operate the flight controls, and hydraulic power for deploying landing gear and actually controlling the flap actuators and to be able to steer the aircraft. So you need that electric and hydraulic energy. So the forms of rat we have are either an electric rat, which would just have a generator being driven by the turbine. And then an external piece of equipment would be the EMP, where now we have a hydraulic pump being driven electrically by the rat. Or we have a hydraulic rat with external HMG. So in that case, we have the turbine driving a hydraulic pump and then providing hydraulic power to drive an electric motor generator. And now most recently, we're developing hybrid rats where the turbine actually drives directly a pump and a generator to provide that power to the aircraft. So real quick here, just some more notes on the configurations. Our hybrid is the most efficient generation of emergency power due to just the fewer energy conversions. But it is, as a module, it is higher in weight, complexity, and cost compared to the hydraulic, which is really our oldest and probably most common form of the Ram Air Turbine. It's the lowest weight, and electrical, again, so you take a little hit on weight, but you have improved reliability there. So each of them have kind of their pros and cons, and just depends on our customers' aircraft architecture on which approach they like. Some ranges of size here. You can see the turbine diameters can range anywhere from 13 inches to 64 inches. So a pretty significant range as far as our product, but you can see or imagine compared to the size of the aircraft, this is a very very small product in relation to the rest of the aircraft. As far as power being generated, between 2 and 75 horse, turbine speeds between 3 and 12,000 RPM. And then as far as the actual electrical and hydraulic outputs, the generator, we have anywhere between 10 and 70 kilowatts or kilovolt amps. Pumps usually generate between 3 and 5,000 PSI, but provide between 1 and 35 GPM of flow, or gallons per minute rather. And then you can see the weights, anywhere between 20 to 400 pounds, again, depending on the size and the architecture, whether it's hydraulic, hybrid, or electric. So a little more detail on the components here. So Collins offers RATs either as a full module, which would include the actuator, the frame, the uplock, strut, everything as a package. But we also offer it as individual components as well. And that affects greatly the design of our wind tunnel to be able to accommodate a wide variety of different shapes and sizes of these RATs and functionality. RATs where we have to actually test the actuator, the uplock, all these features, just adds complexity to the equipment and how we test. A couple photos here. Now you can see a couple installations of a RAT actually on the aircraft, and the relative size of a normal, I'd say the one on the left being kind of an average sized RAT in relation to a human. And then here you can really see it relative to the entire size of the aircraft. If you can see my mouse in this photo, the RAT deployed out of the wing here. So again, this is impressive to me that little piece of equipment is able to provide enough power for that entire aircraft to be able to land and control safely. Okay, so that was an overview of what a RAT is. So now we'll get into how we test it here in Collins for acceptance. So as I mentioned, some of our RATs do include an actuator. So in order to test that functionality, we need to provide pressure to the RAT. We need control over the solenoids to be able to stow it, deploy it. And then as an output, we have to check functionality of the RAT. It's required to actually abort the stow process if the turbine is misaligned. So proper installation or stowing into the aircraft. And there's also requirements for time to stow, time to deploy, that all need to be verified in test in our wind tunnel. The turbine, input to the turbine obviously is airspeed. It requires moving airflow to be able to drive the product. And also to be able to test it effectively, we'll need to be able to vary the hydraulic electric load. And as output, we need to be able to monitor the turbine speed and how it responds to different loads, as well as how much margin there's available on the turbine. As you approach the lower air speeds, we need to make sure that the RAT is going to be able to provide sufficient power to the aircraft, even as it's slowing down on its approach. For the pump, again, tying into a hydraulic system, we'll need to provide a positive charge pressure to ensure it doesn't cavitate while operating. We'll need to be able to vary hydraulic load and test proper assembly, make sure there's no leaks or bursts during a proof pressure test. And then our equipment will need to be able to continuously monitor discharge pressure, what the pump or RAT is putting out hydraulically and flow, and be able to monitor the transients and different loads, make sure there's steady, constant and sufficient power for the aircraft. On the generator side, our equipment needs to be able to control the generator. It's externally excited. So we have a GCU, or generator control unit, that has to be able to regulate the output voltage of the generator or RAT. And we'll need to be able to vary the load on the generator electrically. So again, looking at generator performance, we'll look at voltages, currents, and generator frequency throughout the test. So those are the components on the RAT. So let's start talking about the equipment we need to be able to test those components. So the wind tunnel, although it's the biggest and probably most impressive piece of equipment in the facility, it really does the least. It's a giant motor and fan to generate that airstream. But as far as testing our product, all it does is provide the input power to be able to drive the rest of the functions. Our material handling system, here we use to be able to position the RAT in the airstream, simulate the aircraft installation, as well as the dynamic response and stiffness to ensure we have, and to be able to monitor accurately the dynamic response while we're operating the unit. Our hydraulic system, talked about some of those functionalities as far as providing pressure, sourcing sourcing actuator, the pump, and being able to monitor all the outputs as far as pressures, flows, temperatures, and to be able to vary the load on the RAT. And then electric system, as I mentioned, houses our GCU, our external generator control unit. We need to be able to vary the load and control all the other RAT accessories as far as turbine speed, the uplock, the stow, deploy solenoids. All of that would be tied into our electric system. So now some photos of our facility, starting with the wind tunnel. That first photo is looking at the wind tunnel from our second floor conference room. This, if you can see my cursor, this first piece houses the motor and fan. There's 22 horsepower motor fan combination driven with a variable frequency drive to be able to, the VFD is actually what's controlling the airspeed with closed loop control on a differential pressure measurement in the contraction. So the differential pressure is what's telling us the airspeed, and we use that as feedback back to the VFD to be able to control our airspeed to the RAT. So motor and fan in this section generates the airstream towards the back of the room through the heat exchanger. Without the thermal management, this airstream in this facility gets warm very fast. If you can think about 2,200 horsepower motor fan for a RAT that at maximum requires 75 horse, all the rest of that when you're operating at top speed is thermal losses, frictional losses in the shell. So that heat exchanger is pretty sizable, requires a lot of water flow to be able to maintain air temperature, both in the facility and just for the airstream. One other thing to note is our pitot rake and ring setup. This is how to commission our wind tunnel. We look at the velocity at several points radially from the center line of the nozzle. And this tells us at what point is our velocity starting to taper off. So when we have a rat, that's our larger rats more specifically that have turbines that stretch out near this edge, we need to be able to know how much of that airstream, when we're measuring 100 knots, how much does the turbine of the rat actually feel? So this is kind of an activity, a pre-commissioning and maintenance thing we need to do to ensure that our single airspeed measurement, we need to know what that looks like for each rat. Material handling system. So this was a major initiative for our new wind tunnel to be able to increase uptime of the wind tunnel and decrease setup. Where previously, every time we change over a rat, we have to make the mechanical adaptation. We have to hook up all the different hoses or hydraulic tubing, and electrical connections while the rat is hanging in the tunnel. We worked with our suppliers to develop the system where we can actually mount a rat external to the tunnel in its proper configuration. And here on this rigging cart, we can make all the hydraulic electric connections to a match plate, hydraulic QD match plate. You can see here's the master match plate that'd be hanging in the test section. This includes every possible configuration of hydraulic or electric connections that would be required. So by the time all the rigging takes place external to the test section, we roll it in. Now we can program this automated gantry system that'll pick up the rat, move it over to the match plate where you can see kind of a threaded actuator. We'll clamp the two QDs together, make all the connections within a few seconds, and then from there, take the rat over to the test section. So where in our previous tunnels, it could take between 45 minutes and an hour and a half to set up a single rat, we've gotten that process down to 5 minutes in and out. Our hydraulic system, we have broken up into 3 pieces. We have we have 2 different oil types. We need to our rats operate on 2 different oil types. So we need both a red oil system and a Skydrol or Hijet system. So we have nearly identical systems for both, but our hydraulic power supplies
I believe we may have lost you, Bob.
Yeah, did we lose Bob? Huh.
So I think Bob's having an audio issue. So Dan, I don't know if you are able to talk much about this.
Yeah, he comes again.
All right, sorry folks, we'll get back going again here in a second.
Can you hear me?
Yeah, you're back. Thanks.
Yes.
Oh, did I disconnect there for a while?
Disconnected there for a little bit. So, but
Okay.
Continue. Thanks.
Yeah, my apologies. I think where I left off or I don't know where I cut out, honestly, but.
I think you can just go over the whole slide again.
Sure. So as mentioned, our hydraulic system is broken into 3 pieces. We have HPU, or hydraulic power supply, or hydraulic power unit. We have a valve control. This is really the logic of the system, the configuration, and then we have an instrumentation panel. So those 3 pieces working together make up the hydraulic system for the RAT, and all of it is entirely configurable and controlled with our software to the point where we can fully automate configuration for different tests and automate the sequence. Okay, there we go. Okay, and our electric system, I mentioned some of the features, but really this, although it looks a lot smaller than our hydraulic systems, all the same complexity is there. It's just packaged with smaller components. But this RAT IO cabinet is really housing all the control, all the instrumentation required to test the RAT electrically, with the exception of the load. We have housed in a separate room from the wind tunnel hull. But our load, major benefit from our previous wind tunnels, where we had specific AC loads for 115 or 230 volt, or we had separate loads for resistive inductive load. Now this single air-cooled unit handles our entire suite of RATs. Lastly here, now how, just a quick overview of the site plan and how we fit all the equipment in. Our tunnel hull here is the main wind tunnel shell. Just to the north of it was our electrical room. So that's where our VFD is, our electrical load bank. Really all the major electrical components are housed in there. If you come, this hallway here is coming from assembly. So RATs would show up to the facility through this door, get rigged in this large area here, and then pushed into the RAT staging area onto the platform to be tested, and then flow just in reverse order when that test is complete. Okay, so now I need to pause here. I have a separate presentation for the videos.
Do you, does anyone have a question? He might take one or two before we go into the, John, what do you want, how do you want to handle this?
Yeah, so folks, if you have any questions as we go, put them in the chat. We'll moderate them out at the end, but since we do have a small break, we'll go ahead and ask one question right now that has come in. And this is from Mr. Ken Cinco. We'll go ahead and let Ken ask one question, then we'll move on to the videos. Ken?
Yeah, I was never aware of such things as these auxiliary RATs that would probably be on aircraft I've flown on. It makes me wonder how they are maintained and tested once they've been installed in a commercial aircraft. Are they occasionally deployed just to make sure they work? They seem like emergency devices that would be like lifeboats, and you want to make sure your lifeboat can float. So I'm wondering what the maintenance and testing of them in service is.
Yeah, that's right. They do. They test it a couple ways, and I don't know the cadence on each, but they will actually deploy the RAT in flight. I assume not always with passengers on it, but just as a maintenance flight to ensure proper function. But they also do ground checks on the RATs, where they can hook up they call it a back drive motor. So on the back side of the turbine, there's like a spline interface, where they can hook up a hydraulic motor to it just to spin the turbine and look at the output of either the generator or the pump while it's on the ground. So you don't get as much power or speed from that back drive motor as you would in the air, but you can at least check proper functionality that way.
Okay, Bob, let's continue with the video.
Okay. Oops. Okay, so this first one is kind of just a walkthrough of the facility. If I can get it started. So this would be entering from that, from assembly. So this is that main hallway. We have the automated sliding door there for so material handlers don't have to deal with anything. But you can see kind of our in bay. All those blue totes are actually rats currently waiting to be tested. In the left here, once we start commissioning more of our rats, this is where we'll store all the tooling, all the specific equipment for those. So we're approaching here our 3 rat garages. I didn't speak to those much earlier, but there's several tests that we do currently in our existing wind tunnels that are just static pressure that we don't require the wind tunnel to be operating for. So again, in an attempt to utilize our wind tunnel more, we've been able to develop a separate hydraulic system here where we can test our longer duration static pressure tests outside of the wind tunnel section. And one piece missing from this rigging room that we don't have yet, we're gonna install 2 rigging, de-rigging gantry systems. So there'll be 2 machines that'll aid in the rigging of our rats. So as you can see, some of our rats show up in those blue containers, and getting those safely pulled out and mounted into our fixtures, it can be tricky depending on the rat and the angle. So we're working with a supplier still to install these unloading gantries that should aid in our ability to install a rat on the portable rigging fixtures. So now,
we lose Bob again.
I believe so, Bob. We lost audio.
We lost audio, Bob, for a minute.
But we can see you.
Can you guys hear me now?
Yes.
Yes.
Is there audio on the video also?
Well, I might have to work on settings on that. Continue and I'll try to get that going.
Okay. I don't know if that's on my end. Actually, I have an option just to share sound here.
Yep.
Okay.
There we go.
This, again, the tunnel hall. So on the back side, you can see the area. It was actually surrounded by, I think they call it level 5 or level 8 ballistic glass. So it's actually bulletproof glass protecting both our operator in the control room and anyone walking behind that viewing section into the utility rooms. And then here's kind of the first look at the test section without a rat installed. In the next video, we'll look at the process here. So right now, to start, we have a portable rigging fixture on the platform and pinned to the ground. So the gantry knows exactly where the rat and the tooling is. Start the video. So the only thing needed now to install the rat once it's here, you can see down at the bottom was our touch screen. All you need to do is select which rat is being loaded. And you swipe your finger for confirmation, and it'll initiate this entire sequence. So the gantry will pick the rat up off of the portable rigging cart, bring it forward so the turbine clears the rest of the fixture. And once it gets to a safe height, it'll pause, prompt the operator to remove the cart from the platform so it can continue the rest. Now the cart has been removed. Gantry's been reinitiated, and now it's heading over to that master match plate where it'll make the hydraulic and electric connections with the rat to the rest of the facility. So there it picked up the match plate, and now the actuator is starting to clamp the master to the unit-specific match plate. So it's hard to see there, but if you saw where my cursor was, you could see the plate being driven down to meet the rat.
Mm-hmm.
So that process completed. Now the gantry takes the rat, and you can see the bundle of hoses, electrical cables, feeders, everything now along for the ride. While the gantry takes the rat to the test location. So then, once it's in that location, it's ready to test. So the first video here, I'll show wind tunnel's already on, but at a low airspeed below like the minimum required to start turning the turbine. And what happens is we'll ramp up the airspeed to that minimum threshold, and you can hear the turbine. It takes off. Once it gets going, it takes off pretty quickly and immediately starts. So this, I should have mentioned, is a hydraulic rat. So once it gets to that steady state turbine speed, it's providing 3,000 PSI, and I think in this case, 5 GPM of flow or hydraulic load. So then one more video. This last one showing it already at speed, but our operator has initiated an automated sequence for step loads. So here you'll be able to hear, you can actually hear the change in turbine speed as those different loads or air speeds are being applied. So this one's about a minute. I think this one's fairly loud. I'll just let it play. At each of these different steps, I forgot to mention our software is bringing them to each condition, but it's also looking at the outputs as far as turbine speed, hydraulic pressure, and everything. Recording data through that step load and ensuring that the response is acceptable. So our software is actually on the fly making the determination whether it's acceptable to move on to the next step or not. So that was, I think that's all I've got as far as my presentation. So I think open it up for questions now.
Yeah, great. We'll go ahead and open it up for questions. Bob, first of all, thank you for that. We'd love to host a live tour. Looks extremely interesting. So the next question is going to go to Mirana. I'm going to go ahead and allow you to open your mic, Mirana, to go ahead and ask this question if you'd like.
I just wanted to say that I had a chance to participate some production flight tests that I was flying with, and that we were testing the RATs and IDGs as a part of certification of the aircraft, and that was very nice. And thank you for putting all this development for us who fly the aircrafts.
Very good. Thank you, Mirana.
Thank you.
We now have another question from Mr. Ken Cinco. Ken, go ahead and ask your second question.
Yeah, I was recalling that the temperature of air at altitude is really quite cold, and I wondered if the airstream that your RAT experiences under test is at a comparable kind of temperature, or is that something that's really not a consideration for these tests?
Yeah, that's a good question. So our facility, at least here in Rockford, does a much better job at simulating more ground level or ambient conditions. When we qualify the RAT, we'll go to a separate facility that can actually test at altitude and temperature. But our facility here in Rockford, at least for testing for production or acceptance testing, is more ground level ambient.
Okay. Very good.
Ken, I think we also do, Bob, correct me if I'm wrong, some of those mid-air environment, there are a few other ways to simulate the environment than up in the air, where the air is very thin and not as dense as on the ground, by varying some of the parameters of the RAT to actually, without actually having a very thin air on the ground, actually create an environment that will simulate that so that we can test the RAT in those conditions.
Thank you.
Very good. Yeah, any other questions for Bob? Okay, it looks like that's all the questions we had. If there's not anything else, we'll go ahead and conclude the presentation. Again, Dan, thank you for arranging this with your colleague, Bob. Everybody keep in mind that event we have coming up in November at Elite Electronic Engineering here in the Chicago area. That will be face-to-face. We hope to see you there. Registration information should be coming out very soon for that event. So with that, we'll go ahead and close. Thank you, everybody.
Thank you.
Thank you.
Thank you.